Kent, we go back a long way. You put me in for Oracle Ace Director, and I
Yeah.
think you are, and that's, thank you very much. Now I'm going to actually go to my phone because you have accomplished more things than I can rattle off the top of my head.
Okay.
All right. Because if I don't go to my phone, I'm going to miss something important. So let's see. So this is Graybeards number 4, and we all have our gray beards. We brought them with us. And pretty much war stories. So 1, you are a recognized industry leader, data warehousing, artificial intelligence. You have spoken all over the world. We all go back enough years that we probably, a lot of the people coming in when they were children are now adults. Semi-retired from Snowflake.
Mm-hmm.
All right. You and Data Vault. And I remember, because I'm a security guy and there's Oracle Database Vault, and I read, oh, Data Vault. Therefore,
I remember.
Ken must be a security guy, and you had to educate me on what Data Vault was. So you've got a crap load of experience, but you're also into martial arts. And I'm not going to try to pronounce all of this. Chung Hoon Ti Kwon-do, 42 years?
It's a Changhan Taekwondo. Yeah.
Oh, Chang Han Taekwondo, 42 years.
Coming up on 43 now. That's right.
43 years.
Jeez.
8th degree black belt grandmaster. Tai Chi. I enjoy Tai Chi, actually. I do that for relaxation.
Mm-hmm.
Aikido, judo, and all of these other things, which I actually consider meditation. Thank you for joining us. Kent, it's been a long time. The last time we talked to each other, I think you were actually at my house.
Oh man, yeah, it's probably the last time. Is that the last time we've been together in person? Yeah, because I was there speaking at a data science meetup at a little college not too far from where you live there, outside of Baltimore.
Yep. That's been a long time.
I think it was like the Maryland Data Science Meetup Group or something like that.
Well, Candy says hello. My wife says hello.
Yeah, tell her I said hi. Yeah,
I will.
Yes, and I still have not ever gotten back to Maryland to try any other crab cakes than the ones that you took me out to dinner for.
Oh yeah, that's right. Well, you need to. We all need to just get here, do crab cakes. I'll be putting the boat in the water next month, and I know the perfect place to go.
Awesome.
All right, excellent.
I think that's a great idea. We can do a Graybeards from one of the crab shacks on the Patapsco River of the Chesapeake Bay.
Oh, there you go. There's an idea.
I like this. What do you think, Roger?
Yeah, let's go for it. Go for it.
Oh gosh.
So what do you want to talk about?
To take out the background noise.
Yeah.
I got a quick question, because he did mention martial arts, and I had this friend who was doing, I think he was going for his 4th Dan Taekwondo and stuff like that, and he had to do like this incredible like jumping, spinning around kick, and I've done jumping, spinning around side kicks, not that impressive really, to be honest with you, but I think it was the height that he had to do it at or something like that, but it was like an incredible sort of flexibility thing at his age, like let's say maybe mid-50s or something like that. And
wow, that's impressive.
I'm thinking to myself, I don't know. I'm pretty confident that there's no way I would have been able to do that, even though he was like training for like a year or 2 for this thing.
Yeah,
how do you do it? You do all those fancy things like that?
Oh yeah. No, I do jump spinning back kicks, jump spinning hook kicks, the jump turning kick, as we call it. When I tested for my first Dan, I was in college, and I had to break a board with a flying jump front kick, but they held the board like this, but the guy was standing on a chair, somebody like Robert's size. And so it was, and I'm all of maybe 5'6". So I had to be able to go way up in the air to do that. I think when I tested for my fourth degree, I actually did a flying 360-degree jump back kick, and I had to jump over a person who was bent over at the waist and break the board on the other side. That was fun. That was a lot of fun.
Incredible. And also, like with the Tai Chi, I had a karate instructor who basically said, you can use it for self-defense. So in other words, the movements are not just for relaxation, that type of thing. I mean, they are definitely intended for self-defense and that muscle memory type of thing. Yeah,
the original form, which was the form that I studied, which was Chen style Tai Chi from the Chen village in China. I mean, it was a martial art. It is a martial art. Today, a lot of people just teach it for meditation and relaxation, and many of the Tai Chi instructors don't know the self-defense applications of the various moves in there. And so when I tested for my sixth Dan, I had learned a Chen long form. And so I actually did it at traditional speed. At traditional speed, that form takes anywhere from 20 to 40 minutes to complete. And then I did it at an accelerated speed using my Taekwondo brain so the audience would see some of the applications, and then actually did a self-defense demonstration with some of it with one of my black belt students, and explain, okay, here's this move, and here's what it does. If somebody grabs me here and I do this, he goes down, right? And was able to go through and explain that, because a lot of people don't know that Tai Chi really is a martial art. It was, a form of Chinese boxing is what it translates to. Today, more people do it for relaxation, but yeah, it was the opposite of the styles that, Taekwondo and Shotokan, where were considered external hard styles, where we did everything at speed, very hard, very forcefully, break boards, all of that. Tai Chi took exactly the opposite approach and does the motions very slowly, but you do them over and over and over again. Then, like you said, it's muscle memory. Then it's boom, it just happens. And it works. It's just as effective. It's just a little more mysterious to people on the outside looking in.
Yeah. All right. Thanks.
The one thing I think when I think about Tai Chi, I think about vectors. I mean, it's like when I see Tai Chi, I see vectors. Because when I learned Tai Chi, okay, my hair was still black. Which was a long time ago.
As was mine, yeah.
Yeah. I learned it for a meditation purpose, because I was so stressed out. I needed to come down like 27 notches. But my instructor taught me something called, I think, what was it? Pushing hands, moving
push
hands.
Yes, push hands.
Push hands.
Love it.
And I was like going, oh my God, this stuff is deadly.
Well, and I should tell you, I got started in Tai Chi for exactly the same reason. I was already probably at least a third degree black belt in Taekwondo, working at the Denver Veneral Center, which is where I learned Oracle. And one of the other members of the Rocky Mountain Oracle user group, Jeff Meyer, who is an Oracle DBA, is also a Tai Chi Sifu. At the time, he wasn't. He was just starting. And he and I got into this Tai Chi class together they had a little fitness center there. And, he and I had been working on, I think we were building the ARMA membership database after hours. And then we ended up doing this Tai Chi class together. Well, he, went off. I went off to another job, no longer on the Federal Center at that time in the early 90s. But he got so interested in it, he and another buddy of his went off and found a legit Tai Chi grandmaster in San Francisco. And for the next several years, he was flying out to San Francisco at least once a month and training with this guy, and eventually brought him to Denver to their dojo there. And I got to meet him. And then I started learning that style. then Jeff worked with me at Quest Database Consulting for a number of years. And he and John Arlen and I practiced Tai Chi at lunchtime in the parking lot outside the consulting office for 5 years. It took 5 years to learn the Chen Long form, and I learned it from Jeff in Oracle DBA.
Okay.
And that was that's how I got into it. And then I in turn started teaching it to some of my Taekwondo students. But Jeff and I were both doing it for the same reason as you, working in the Oracle data world, and needed to relax a little bit. So, hey, let's do this at lunch, because we both came from hard martial arts backgrounds as well. And so we did that, and it turned into a beautiful thing, as they say. Tai Chi and data.
You want to know something? I still do the Tai Chi. I still do the Shotokan. I have no idea if the form is accurate anymore, because the last time I had a sensei in front of me, it was 1985.
Yeah, that's a while ago.
Yeah. But you want to know something? If when I'm done, I'm not wanting to chew somebody out, I say it worked.
Yeah, there you go. That's it. Exactly.
Mhm.
Exactly.
Mhm.
All right.
Wait, no, wait, I said 1985. I should have said 1994. I started the Tai Chi in 1994.
Yeah,
And so,
very good. Yeah. All right. So what have you been up to these days, Robert?
oh God, let's see, Incatech. Let's see, I spent some time in Saudi Arabia working on a security issue. Doing a lot of what I call sharpening the tools. If I'm not actively consulting, I am sharpening my tools. So when I walk into a client, my tools are sharp. I mean, it's like you're constantly trying to get
Right.
better.
Yeah.
I'm 62 years old. I think I am number 2 in this group. I know, Roger, you're a couple years older than me, and Kent, you're probably a few years younger than me.
Nope.
Oh, okay.
We're the same age.
Oh, okay.
Yeah, I know.
But
It's my youthful appearance. It's from that 40 years of martial arts. Keeps me young.
But with me, I have a lot of my work has been sharpening my tools, and a lot of spending brief times with clients and client teams, getting them back into the right direction. Of course, my world is in data security, database security, to be more specific. And so a lot of what I do is somebody gives me a call and I say, okay, they say, I have a problem. I spend a few hours researching their problem, and I come back to them and I say, well, if I were you, this is how I would solve the problem. You know, it tends to work.
Yeah.
I've been spending more time flying and working on the airplane.
Yeah, I've seen your pictures there.
Mm-hmm. Mm-hmm. I plan on going out tomorrow afternoon because it's going to be very nice. I'm going to take it over to probably, I'm going to say, South Jersey, or I should say Jersey. There's a nice little town. It's a beach town at the very southern tip of Jersey, Cape May.
It may. All right.
Yep, I'm going to probably head over there and have lunch. And getting my boat ready to go back in the water. That's what I've been up to.
Great.
And you've retired from Snowflake.
It's been
2 years,
a little
year
over
and a half.
Yeah. Well, yeah, I guess it is coming up on a year and a half. Yeah, it was December. Yeah, December of 21. So just a little over a year now.
Yeah, so you're retired from Snowflake, a billionaire with a B.
Yeah, no.
No, you're one of the original Snowflakers.
Well, I was actually when I got looking at it, turns out I was employee 103.
103. Okay.
103. I was 103. So yeah, I joined in 2015. They were founded in 2012 is when Benoit and Thierry started it, was 2012. And the first GA release of Snowflake was June or July of 2015. So I came in right after they'd, kind of gone out to the world with the product.
Mm-hmm.
So yeah, very early, it was only in the United States. There was maybe 3 sales guys. There was a guy on the East Coast and a guy who had basically was in charge of everything from the Mississippi West, and a couple folks in San Francisco for sales. So it was a small team when I got started. Like I said, it definitely was more engineers than anything else at the time. A couple of finance people, a couple of marketing people, and some business development reps who were fresh out of college, hitting the phones, calling people and saying, "Hey, do you have any problems with your data? Do you want to put your data in the cloud? Let me tell you about Snowflake."
Interesting.
What I remember most was it's a painful memory maybe for you, but it's definitely a painful memory for me, because I was looking forward to catching up, was a ACE directors meeting prior to Open World.
Yeah.
I saw you the evening prior to that.
We met at the pizza place.
Yeah. And then it's like, where's Kent?
I was banned. Yes, I was banned.
You was banned. And that was painful for me because I was looking forward to catching up with you.
Yeah. It was certainly shocking to me as well when I felt bad for I forget which of the ACE reps got the displeasure of having to tell me I was not allowed to attend the meeting. And I happened to be, I was in town that week anyway at Snowflake headquarters. But the powers that be up the food chain had decided that since I worked for Snowflake, and I couldn't come to the ACE meetings anymore, any of the ACE director meetings, because I might disclose proprietary information somehow that would make a difference to Snowflake, which of course we all signed non-disclosure agreements, and so it was I'll say slightly offensive to me that they thought I would do that. And it's like, in reality, those meetings, they told us what they were going to announce in the keynotes 2 days from then, so that we could write blog posts and have them ready to go out. It's like there's nothing actually secret being revealed at an ACE director meeting. It's just to give you a little heads up of what Larry and everybody else is going to say when the conference starts 2 days later. So yeah, it was very unfortunate, and certainly a number of other ACE directors have. I managed to put them in the same situation by recruiting them into Snowflake, and they got the same letter after that, and hence was invented the Oracle ACE Director Alumni.
So I think Rob forgot to tell you that or announced that the stories you're about to hear are true. The names have been changed to protect the innocent, and then of course also that the statute of limitations
has expired
on most of these.
Actually, the statute of limitations has expired. And also, Kent, I did not tell you, anything you say can and will be twisted to be used against you.
Oh, well, yeah, I assume that. That's all. That goes without saying. That's the life of an evangelist, man. All the time.
Amen, brother. Amen.
Yeah, I mean,
I'm not going to tell you where I first heard that. But you want to know something that's true? In our world, if we say something, okay, if you can't say it's technically accurate, 1 + 1 = 2, okay? If you say something that this is my opinion, it will be twisted to be used against you eventually.
Well, and Yeah, it can be taken out of context. If you
Oh,
rambled on for 15 minutes, they'll find the one sentence that sounds controversial. And then
you
put
want
that
a
out there.
comfort? I can give you a controversial sentence.
Hey, it's your show.
Go for it. As long as the names are changed to protect the innocent.
Or guilty, as the case may be.
Change to protect the guilty. And you want to know something? A lot of these kids have no idea where that expression came from.
No, I'm sure.
Mm.
So what have you been up to, Roger?
Oh, well, a lot of things. I actually worked for a big pharma for 33 years, and then 2 years ago they were sort of restructuring, and I had the opportunity to take the severance package, which was a little bit too big to
Too big to turn down.
turn a blind eye to. So I volunteered for the severance package, and I thought, to be honest with you, at my age, that it would be difficult to find a job, but I actually had to turn jobs down, and I wound up here with the job at Accenture, and I had some friends who were involved with Encatech's founding and so forth, so that helped. So I'm happy to be here.
Another
But
guy with a baseball cap, if I recall,
yeah,
long hair and a ponytail.
exactly. We have him on tap for an interview coming up.
Oh, good. There you go. Okay, yeah, get the other hat on. There you go, Robert. Cool. Yeah. Yeah, no,
it's been good. And I do primarily performance stuff. I did write a book on Oracle performance analytics. Essentially, it's an anomaly detection mechanism using straight SQL, but it works pretty nicely. I use it regularly for solving performance problems. So
yeah, no, you talk about things that the new newbies in our industry don't understand is how much you can do with SQL.
Yeah, exactly. Yeah, I tell you what, I got a hook because I've been using Oracle since 1985. And one of my first projects was I had to convert a program, and I think it was doing like some type of scientific probit calculation or something along those lines. And it was something like maybe 600 lines of Fortran code, and I had to convert it to Pro Fortran.
Oh, wow.
I'm looking at this thinking to myself, this is going to take me 2 weeks to do this. And I start scratching my head. I said, you know what? All they're doing is updating a table, right, with a value. And guess what? I don't even really need to update the table with a value. I just need to wrap it with a view and do it in a single SQL statement. So I finished it that afternoon. I said, I like this. I can save a lot of time.
It's right. Yeah. It's a very elegant language. And if you understand the set-based logic and all of that, you can just do so many things with it. Yeah. I when I got into data warehousing in the mid 90s, we didn't have a lot of fancy ETL tools back then. I was loading the first data warehouse I worked on with insert statements, but the insert statements were pulling from a view. So I did all the transformations in a view on a stage table, use SQL loader, load the data into a table that basically mimicked the source, put a view on top of it to do the filtering and apply the business rules, and then just do a select for, insert into target table, select from view, and that was it.
Yep. Yeah, I mean, I think today we're still using that same concept, to build data lakes and stuff like that, because then you can sort of embed the complexity of the data model, from the source application right there in those views, and not get involved with, now you have to reproduce all this sort of logic and how you join these tables and so forth now in the data lake.
Yeah.
Gentlemen, I am the non-data lake data warehousing person. I have a really stupid question. There are no stupid questions. What's the difference between a data lake, a data ocean, and a data river? Because to me, I hear data lake, and to me, a lake is
you're thinking
between a pond and a lake and an ocean. It's a lake.
Right. Yeah.
Okay. But then I think rivers, the data is flowing. The data is constant. And then there's the ocean, which is like, never try to boil the ocean is a piece of advice I once got.
Yeah.
So when you guys think about these concepts, I hear data lake, which is, to me, it's a mid-range piece of data. But the river, as the data is flowing into the
They would call that hydration. Normally, I think that,
At one point, yes, people did try to call that hydration. Of course, nowadays we talk about data pipelines, so we've completely changed metaphors, right?
okay.
Because you went from being an ETL developer to being a data engineer. And so what do engineers build? They build pipelines.
Mhm.
Except this one has data flowing through it from the data lake into the data warehouse in many cases. But yeah, nobody ever used the term. I mean, you're not wrong on your analogies there. It's like, why did we call it data lake? Because data pond sounded too small. And I did an article a couple of years back where we talked about the fact that many organizations ended up with multiple data lakes, which really were separate data ponds. And effectively what they did with data lakes is what people had done in the data warehousing world. They created data silos.
Mhm.
And in many cases, each of those ponds might have even had some of the same data in it. So now you got redundancy when you're trying to bring it all back together again to get an enterprise view. It's like, well, wait a minute, that data is in that pond and that pond. It's like, well, we used to, in the old days, we called that a data silo.
And when I hear silo, I think of a farm where you're putting in the grain.
And I think that's where that analogy came from, was that idea of stacking up the data in a silo. And it's completely separate and it doesn't
Mhm.
mix, right? But when you're trying to, where the goal, Bill Inman's original concept of data warehousing was to integrate all that data from all the different sources in your organization into a data warehouse so that you could get the complete picture. And what you ended up with is people building these little star schemas to do, I'll say, point analysis,
Mhm.
answer specific questions. And in the end, you ended up with all these different data marts, which were effectively data silos. They weren't integrated at all. They were maybe all pulling from the same set of sources, but you would have data going in the same data going 5 different directions and potentially getting tweaked, transformed, changed 5 different ways. So of course, nobody could ever come up with the same answer. And it was kind of that, just got very convoluted there. And the data lake world came along. It's like, oh, we're just going to we need to keep all this data. So we're going to put it in a data lake, which of course at the time was going to be in Hadoop, because Oracle, Teradata, SQL Server, all of those, the hardware is too expensive to store all that data. It's going to cost us too much if we try to put it into a database. So we're going to put it in a data lake, which is just a bunch of files in Hadoop. And that rapidly turned into what we affectionately call the data swamp.
Do we have a data creek?
No Data Creek.
Oh, okay.
No.
Because when I hear data, when I think data river, okay, data is flowing. Okay. I want the data that is now. If I need to make a decision, I need to make the decision on data.
We call that streaming now.
Oh,
that's streaming.
Can you do a blog post and tell them to call it river? Or at least estuary.
Estuary, but yeah, estuary. Then it's not moving so much. Yeah.
Yeah, I'm on a water thing,
Yeah, apparently.
I'm looking out my back window right here, and I'm looking at Marley Creek.
Yeah.
So the guy who invented the waterfall model, or the metaphor for the waterfall model, and for some reason his name doesn't come to me right now, but anyway, he said that he presented that as a joke, and then
yes, and it became our methodology. Yeah,
exactly.
Until Agile came along, it's like, yeah, that was not supposed to be a good idea. I remember seeing an article on that. He's like, this was just not. This is the way people are doing it. I didn't mean to imply that's the way we should do it. And of course, that's what we did for about 20 years. it just caught on. It's good buzzword. Oh, we're going to use the waterfall method of project management and design. Yes, we're just going to do that.
And I used the term buzzword bingo in an email today.
Of course. Yeah.
Hey, here's a question for Ken. I guess a lot of people talk about this sort of schema on read type of methodologies,
Yeah.
dumping massive amounts of data into their data lake, and then they're trying to, I guess the idea there is figure it out later. And
yeah.
And I guess some of that comes in with like the JSON data structure, where you don't really have a defined data model. You just kind of invent your data model as you go type of thing. And I see a lot of those things, not necessarily impediments to get, they're definitely not impediments to getting the data in. They help you get the data in faster, but then making sense of it. So in other words, without some type of comprehensive data dictionary, seem like your host with
yeah. You hit, was one of my I gave several talks on this while I was at Snowflake, because Snowflake invented a data type that would natively ingest semi-structured data like JSON and XML, and then you could actually write SQL against it, and it was just built in, right? It was built in that you could do this. You could write SQL statements, and so we had a lot of customers that were building data lakes, loading in JSON documents, as they're called, into tables in Snowflake using this variant data type, and then putting views on them for their data warehousing and their analytics. And over time, Snowflake evolved various functions and methodologies to make it easier, and some tools have come along that can now look at it and discern the structure. But I remember, I think I gave this talk at probably RMUG and maybe even ODTUG in my early days at Snowflake, was how to explain this to people who understand structured data. Because you're right on, the idea of schema on read is that it's going to allow us to build faster, because we don't have to waste all this time doing upfront data modeling and defining tables and columns and data types, only to figure out that we got it wrong and we got to make changes. And those stupid data modelers, they take so long to do all of that. It's years. We don't have years because we're building web apps, right? And so that was the idea of the schema on read, is that we can drop it in there. To a certain extent, they're self-defining structures. And what I discovered once I got into it and doing the reverse, how do you pull it out in Snowflake and write SQL for it? And it was very, very fast. Oracle had it very early on, but there were some special functions that were necessary to make it perform in Oracle. But they were doing it before Snowflake. But Snowflake came up with a new data type to make it optimized, which made it as fast as any other query. But when I got looking at it, it's like, well, they have basically tags, or what we would have called columns. As you go in there, there's name, colon, double quotes, value. Okay. And once you figured out how to traverse that, and Snowflake built some SQL functions to allow you to traverse that, I wrote a whole ebook on it to show people how to pivot that and turn it into something that looks like a table through a view. But in the process of doing that, I said, well, schema on read doesn't mean there's no data model. There has to be a data model. The term schema is another term for model. So if you say there's a schema on read, well, okay, then there is a model there. You just don't know what it is until you try to do the read. And so I went through and started taking JSON documents and decomposing them into entity relationship models, and into data vault models, and into star schema models, and saying, look, you can take this data in a JSON and represent it in whatever modeling technique you want. It just happens to be that it's variable in that you could have 10 attributes in one record and only 5 in another record, but they would still be the same. There would be the overlap. So you might have name, address, zip code, phone number, email. Well, the next record might not have email. And because it doesn't have email, the tag email won't be in the document. Right? Well, okay, that's a null. Right? And so you could actually put all these together and come up with a model. And by virtue of that, you say, okay, these ones are mandatory because all the records we have name. All the records we have address. So we could call that a mandatory column. But they don't all have email. They don't all have phone numbers. So those are optional. and you could actually put a model together and put a view on it so that then a report writer or a business analytics person can then look at it and go, oh, that's the data I had. Imagine a data scientist, because this was the big issue in data lakes that turned into data swamps, is they threw all this data in, this semi-structured data, and then told the data scientist, to go build algorithms and machine learning and come up with inferences. And they're looking at it and go, I don't even know what's there. So if you figure out how to depict that, again, we used to call those data models. Here's a picture. Here's what all the variables might be in there, right? And here's what they're called, and here's a view that shows it to it. So you just select from the view, and if the stuff wasn't in the document, well, those columns are null, and where the data is there, the columns aren't null, and it's all there for them. So it was very interesting, because when I first got into it, people they kept saying, oh, we don't need no stinking data modeling, right? Yeah, and there's no model. It's schema unread. It's like, listen to your words. Schema means model.
Exactly. Actually, I have another sort of side question on that, and that is, I did play around a little bit with MongoDB and querying JSON, and part of it my question might be because of my lack of experience, but it seemed like you still needed to know, like, the key value pair structure. I use that all the time in a relational database.
Absolutely.
But I don't have to know necessarily what the key is in order to query it, right? So I have a column called metric name, metric value. So there's my key value pairs. And then I can go through the metrics I don't have to know the individual metric name. But it seemed to me like in the MongoDB, when I wanted to query that JSON document, I needed to know the name of that key.
That is the downside of the schema unread. So you had to come up with a way to reverse engineer that to know what it is. And a couple of tools have come out over the last few years that are able to read JSON and translate it into a data dictionary effectively. But the downside of it, the flexibility was we're going to write as fast as we can, is that and this was very annoying, because it's flexible. If you had an attribute name, right, and you write a record and you have the key, and the key's name is name, and you put the value in, but then the next programmer comes along and he types it wrong. It's NAM instead of NAME. Well, it'll still insert it.
Exactly. Yeah.
Right, because there's not a fixed schema. And so when you go to query it, you're not going to find 5,000 rows with NAME and one row with NAM. And go, what the heck happened here? So now you have the ability to introduce data quality problems faster because of that. But yeah, you're right. You have to know the attribution of the key in order to know that it's there, in order to query it and pull it out properly. Otherwise you just you dump the whole document. And that's how I learned. It's like I dumped a couple of JSON documents and looked at the structure and went, okay, key, value, key, value. And then there's things like arrays and nested arrays. So I had to learn how to decompose all of that. And what's an array? An array is just a table.
Exactly.
Right?
Yeah, that's what I was going to say.
It's a denormalized tables. It's what we called in third normal form, not third normal form, repeating values.
Exactly.
Right. You've got a phone array that has 5 phone numbers in it. Okay. Well, if we were doing that in a database, that would be a table with a phone column and 5 rows. If you're doing it, basically a zero normal form, it would be a spreadsheet with 5 phone numbers. 5 phone number columns. You have phone 1 through 5, but then of course, what happens when you get phone 6? Okay, now you got to add another one and another one. So really interesting looking at that and translating those structures into basically relational theory, into a relational model. And so you could have a JSON document with all sorts of nested arrays and nested keys and all sorts of things. And that one JSON document could constitute what we would think of as an entire application schema with 15 tables with master detail relationships in them.
So yeah, so one of the I'll sort of run this one by you too, because I've made this sort of statement and to other people, and I've sort of mused in my own mind about it. But relational databases came along at a time where when disk space was very expensive, right? So it's optimized to save disk space. And it also came at a time where we had hierarchical databases where you had to sort of hardwire your connections. And if you had a different connection, you had to, sort of restructure your database and so forth. So relational solved that. But also now, like in the sort of, I guess, age of streaming data or click streams and all this kind of stuff, massive amounts of data that's coming in, that some of these structures seem like they're suited, better suited for that, where you don't necessarily need to know an exact structure of your data. Because let's say you're also building business applications, in the old days, like I'm building a payroll, or I'm building a, kind of like a standard business application. Most of those applications have been built already, right? And you can just get them. But now the new applications that are coming up are more sort of free, or data types are not necessarily all known in advance and all this kind of stuff. So it's kind of like solving a new problem with the JSON and the other more flexible data structures.
Though I would, the converse of that is it's bad engineering practice, because when I was being on the receiving end of that, since I've been doing data warehousing since the mid 90s, is one of the things that I discovered in trying to build data warehouses with like 15 different sources, is you would find just even, what should have been relational databases where the controls weren't put in place, and this undefined data types where you're putting numbers in and dates into varchar columns makes it a lot harder to do the reporting and do the analytics. And so even though you may, taking these techniques, it allowed people to be very agile in building new web-based applications. In particular, it really started in the early 2000s, as far as I could tell, being able to, take stuff off of a web page in the .com era before it became .bomb, and enter the data in and have it, get pushed out. But the back end processing became very convoluted because there wasn't a defined schema. It's like, so how do you write a report to answer business questions if the schema is potentially changing daily, weekly, monthly, whatever? It made it hard.
They just tell you that the data scientist spends 60% of his time prepping data.
80. And we're trying to reduce that with getting smarter algorithms and things that can do automated data profiling. And so we've got some of that, but in reality, everything has to have some kind of a structure. And yeah, you don't want to take 6 months coming up with what that structure is. But if you're thinking on an end-to-end process, you got to get the data in, great. But what do you need on the other end to get the data out? And how much effort is it going to be to get that data out and make it useful to an organization? And that's where data warehousing and data lakes and all that came in. And those of us on that end of the world having to do data engineering have had to do a lot of work. Data scientists having to do a lot of work because there is no data dictionary and maybe no data quality standards being applied on the input side, because nobody's thinking all the way through to the end of how are we going to make use of this data. I even ran into on one of my projects a bunch of years back. They were using it was a warehousing software. It had no reports. It was all data entry. I take that back. There was 3 reports, but they weren't dynamic. You pushed a button and you got a PDF. So you couldn't even put it into Excel to do any other analytics on it. And so our job was to build a data warehouse basically for that and pull it out so that they could do the analytics, because the software company, when they built this off-the-shelf package, that was the only thing they were thinking about, was we want to enable people to track their shipments and sending and receiving, and the trucks coming in and the trucks going out. And we want to make the data entry as easy as possible. But nobody apparently had really thought about, well, why are we putting the data in? We're putting the data in because we want to track. Well, maybe we don't want to go to the screen and basically scroll through 500 records to see where the truck is. Wouldn't it be nice if we could run a report? It was okay. They wrote a couple of reports. But in the end, it didn't serve the company's purposes. So then they had to pay a bunch of money to a group of us to build a data warehouse for them. so that they could do the analytics and really figure out what was happening with their supply chain. And this was way pre-COVID. So I'm pretty sure they're fairly glad that we did that once that happened.
Well, we heard a war story the other day of some folks, and I won't name the company, but a large armored car company, their database crashed and was crashing on and off for 2 weeks. And this database allowed them to track where their armored cars with money in them were. So this was a very bad database fault.
Yeah, that's an issue. That's a big problem. Yeah, I think one of the worst things I had pre-Snowflake was building a big Oracle data warehouse. And Robert being a DBA, I'm sure you'll associate with this, is we did our calculations, our planning, and we figured we're going to need 10 terabytes. Today that doesn't seem like much, but a decade or so ago, that was a lot. And the infrastructure team, whose responsibility it was to purchase the hardware and attach it to the servers and all that, said, no, your department has never had that much data. There's no way you need 10 terabytes. And it's like, well, and I had to try to explain to him, the department's never actually done data warehousing before. They've been building data marts and periodically deleting the data when the DBA said table space was full. So they would go, okay. And this is in a regulated industry where nobody should have been doing that ever. And so they went off and we told them we needed 10 terabytes. They bought the 10 terabytes based on our justification, then gave 8 of them to another department. And they only gave us 2 terabytes. And inside of 2 months, we filled up the space on the server and said, where's the rest of our disk? And it was a 6-week process then to get additional disk space. And in the meantime, their answer was, we'll delete some of that data in your staging schemas. That's our audit trail. But somebody actually did go and delete 3 months, the oldest 3 months set of data. And wouldn't you know, the next month, there was a question, on some of this data, and they could not trace the provenance of that data because it was in the dimensional model in the database, but the source data was gone. And of course, as you know, source data in sources does change over time, right? It's an operational system. Yeah. So even though you knew what the information was about and what it was related to, you could go back to the source system, but all of the data had been updated 15 times since then. So the data that had been staged in what was supposed to be a persistent staging area that was then used to calculate the metrics that were in the report that are now in question, all of it was gone.
And you said a regulated
industry, yes.
As most people probably know, my wife is a certified fraud examiner and a CPA. And she frequently says, what is the source documents? And so I'll be doing, when I had my own company, I would be doing my personal books, and my wife would look at me, go, give me the source documents. And I'm like going, we're married. This is the mortgage. But, it reminds me of, and I'm not going to mention the project because the statute of limitations is not over. Okay, this was fairly recent. Every country in the world was sending data to a system, and it was in JSON. And whoever spec'd out the JSON basically told all of these countries, like, can you give us this sort of data, this sort of information? And so it was coming in all of these different formats, forms, schemas. And so let's just say Slovakia had a schema. had a JSON document that described Slovakia's information. Bulgaria had a JSON document schema that described Bulgaria's information. They were similar but different.
Yeah.
And it was the biggest problem I ever encountered, was to try to sew all of these together to generate a simple report.
See, that's what we do in data warehousing.
Yeah,
That's what we do
exactly.
all the time. That is the definition of the main problem in data warehousing, is the integration of data from disparate sources that may use completely different structures, completely different naming standards, completely different everything, right? Like you said, Slovakia may have had 50 attributes where Bulgaria had 550 attributes. And then you got to figure out where the overlap is, right?
So,
And they're named, and one's in Slovakian and one's in Bulgarian. So the languages are even different on the key value pairs.
I was going to say, when I worked for the big pharma company in the late 80s, having a data model centric type of approach to applications and building applications across different departments and so forth to the same corporate data model was a big thing. But then that VP left and nobody really carried the banner for that, so I'm wondering, from your perspective, when did a lot of companies give up on this idea of a corporate data model? Or maybe they didn't. I don't know. I know in the big pharma they did.
Well, when the NoSQL world hit and the data lake and Hadoop world hit, we got this concept. People said what I had said before. The whole reason for schema on read is it's too hard to do these things and it takes too long, and IT is a bottleneck. So we're just going to go ahead and move with it. So back when NoSQL became a thing, people stopped doing data. A lot of people stopped doing data modeling. And I do some consulting and advising with a data modeling company now, SQL DBM. They have a great cloud-based data modeling tool, and we're doing webinars, and they're now doing basic education webinars on what is data modeling. And there's a lot of talk on LinkedIn about the resurgence of data modeling. And as I said in one of my interviews before, is data modeling never really went away. It did get pushed down in a lot of organizations and disappeared in many organizations. But then there's people like me and others like me who are out there that, we've continued to do the data modeling because we were able to explain the value of it to the organizations we were working with, but also learn to adapt and adopt agile approaches to it. So we're not going in and proposing a 6 to 9 month project with 20 people that's going to cost millions of dollars to do an enterprise data model. We're going to build it incrementally. Because in fact, in data warehousing, really, if you're building an enterprise data warehouse, you are effectively building an enterprise data model. It's just the question of how do you go about doing that? And that's where I got into Data Vault back in the early 2000s, and the Data Vault methodology for modeling, which allowed us to do it in very incremental amounts. And one of the features of that approach is this concept of links. Basically abstracted all the relationships into what we would have originally called an intersection entity. So no foreign keys really between concepts and tables. It's like, if there's a relationship between customers and products, well, we have a customer product link. And that's where we record that information. In the operational system, there's foreign keys all over the place. And we're going to abstract that out so that we can just model what we need right now, but still have the ability to add in relationships later. Or say you do mergers and acquisitions, you get a whole new source system and the relationships are a little different. And you've got different sets of data. Well, it's like Lego. You just you stick it on there, you add it on. Mm-hmm. I guess it's probably more like Tinker Toys, right? You got a hub and you put the stick in and connect another one to it, and you're pretty soon you're building this model a little at a time. And that allowed us to do that and still build the models. And it's funny because everybody has models, even if they don't think they have them.
Mm-hmm.
If the idea of unstructured data. It's like if data is truly unstructured, there is no structure, well, then there's no way to understand it. So even unstructured data has metadata and has structure. Sometimes it's just elucidating that is the challenge is, how do we want to represent that structure? And maybe we don't need the whole thing, right? We don't need to spend 6 months studying it. We just need to pull some of that data into Snowflake and reverse engineer it into a data modeling tool and take a look at it, and then start building some views to connect it together to see what we can do with the data and discover it. And that's really what the data scientists in the end need. They need to be able to traverse this data and all the relationships in it. But somewhere along the line, somebody has to have a model. And every data scientist that I've talked to and said, if I gave you this picture of all the data elements and how they are tied to each other, would that be helpful? And every one of them says yes. Not a single one said, no, give me the raw files with no column headings and let me go figure out what that data is and how this file relates to that file and this file relates to that file. And, let me do that. And then, don't give me actual metadata and information and models, because, I don't understand those. But everyone's, if you say, hey, if I give you a picture, like, yeah, that would be helpful. It would be very helpful.
So that's where the tool set that you were talking about comes into play, that to reverse engineer those models that are sort of embedded in the data structure themselves.
Yep. Yeah. And so there's some are able to read JSON and XML and things like that. And others, are, the traditional, like we always had in the Oracle Designer, SQL Data Modeler, SQL DBM, Irwin, ER Studio, all these ones out there. You just plug them in and reverse it.
Are you able to? Go ahead, Rob.
Go ahead.
Well,
I have a trivia question.
All right, go for it.
What was before SQL Developer, not SQL Developer? What was the data modeling tool Oracle came out with?
Oracle Case?
Oracle Case.
Yeah.
Yes.
The Oracle OCSIG, Oracle Case Special Interest Group.
Oracle Case. I remember a young lady teaching me that in 1995. And then it was Designer 2000.
Right. And then it turned into SQL Developer Data Modeler.
Then Data Modeler.
Yep.
And for those people who are not old enough, let's go back to Data Modeler. Originally, that was Sue Harper.
Yeah.
Who put together Data Modeler, and I think she was also the Designer 2000 product manager.
Yeah, well, she had been involved in even Oracle Case at the end there, right, under Richard Barker and Ian Fisher, and all those guys rolled through, at least through Oracle Designer, and then somewhere in there, then it switched to SQL Developer and SQL Developer Data Modeler.
And now Jeff Smith.
Yeah, Jeff
have
Smith
you looked at SQL Developer Data Modeler now?
I haven't looked at the web version that came out. I am loving
it. There's still a lot that's, I'm still thinking what I could do with SQL Designer. Okay. 2000.
Designer 2000. Yeah.
I could do full generation end to end and never write a line of code.
Yeah. The 100% generation, that was one of my specialties back in the day. Really enjoyed doing that, but now can't quite. But then, hey, I moved over into the data warehousing world, and we can generate the models, and you got all sorts of tools out there now for generating the data pipelines, as we now call them.
But the thing is, if you can generate the model, okay, and you've defined the data coming in, you define the model, okay. It should be fairly smooth. There will be tweaks on the data coming in occasionally. All right, this is a data security guy talking. All right, I'm not a data warehouse guy talking. There'll be occasional tweaks coming in. Then you'll make the occasional tweaks on the data model side, I am with JSON and whatever follows JSON. I don't know. We had XML, JSON. What's going to be the next thing after JSON?
I don't know. We had, I think when I started with Snowflake in 2015, there was definitely a resurgence in SQL and structured tables.
Mm-hmm.
Yeah, the next thing will be whatever the AI can generate the easiest.
Ooh.
Actually, I was going to ask you a question about that. I know we're getting towards the end, but I played around with Chat GPT, and what I asked it to do was create for me a taxonomy of Oracle performance metrics. So I took, like 160 so different Oracle performance metrics and popped it into Chat GPT. And of course, I had to work with it a little bit so I understood what I was talking about. But eventually, it generated me a 2-level taxonomy of all of
Nice.
these different performance metrics, and actually came up with some categories that I hadn't thought of on my own, because I had some of the basic categories in mind, and it filled those in with those metrics, and then it came up with a few other categories. So I was just wondering if you are using AI and machine learning to help build those schema structures.
I'm not yet, but there are companies that have built software, and it's been in the works for at least a decade now. Various companies have had been able to do data discovery, right? It started off with this kind of data quality, go out and scan the data and see how many duplicates there are in a particular column, what the range of values are in a particular column. But now we're getting to the point where I don't know if anybody's really there yet, but they're getting closer to be able to go out and scan a data set and basically infer a model from it.
Mm-hmm.
See what the data types are by doing domain analysis,
Mm-hmm.
and look at two tables, we'll say two tables with data, and go, hey, this column here and this column here, there's a 99% overlap in the values. They're probably related. So maybe we can put a foreign key between those, and be able to recommend, let's say recommend a data model. I don't know how far off we are from, being able to necessarily want to trust 100% the recommended data model, but I think we will get there. And because of the power of the cloud and the availability of hyperscaling compute. I mean, that's the thing that held us back on everything is, right, did we have the power to do it? If you're scanning hundreds of terabytes of data, how fast can you do that? And do you have enough memory then to churn through all of it to figure out these correlations and combinations and associations? And again, with some machine learning and some smarts in it, you had to put a little bit into Chat GPT for it to understand what you were trying to do. With some basic rules in place, can we generate a good model? Can we generate reports and dashboards? And I think we can. We're already there where we can, with a couple of clicks, generate data pipelines, and using some templates, generate data models based on templates. So we'll get there. We'll get there. I don't think we're there yet, but we will get there, and people are certainly trying to do it.
Interesting. So let's see if Rob has any more things, or you have more hobby horse topics you want to bring up. Rob's got he's looking at his phone. His phone's got all the interesting stuff. Hold that thought, everybody.
No, actually, I'm still old school.
Looking at his notebook. Yeah.
Notebook. I just had a flashback to when I first learned data modeling. Okay. We were using stones and bear claws and scratching them into, okay.
Caveman method.
Caveman method. And I remember, and this is just a flashback to interviewing a business unit. And I took the pages that I wrote and I converted nouns into tables and attributes, verbs into functions and procedures. Okay. Do you see artificial intelligence in the near future taking somebody describing this is my business and coming out with a structure of both data and functions and procedures from that conversation?
I think it's absolutely possible. Because even in the data vault world, we talked about that as part of the methodology of interviewing the business and doing exactly what you said to create the model. The problem will be, as I am very fond of saying for the last 30 years, users lie.
No,
And
I'm shocked. I'm shocked.
And they don't do it deliberately. They just, their perspective of the business may not be the complete picture. And part of the skill of a good analyst and data modeler is the Socratic method, asking refining questions. So until we get to that, I mean, we've got to get to that where if the business person says, well, our customers buy our widgets, it has to be able to ask back, well, does every customer buy every widget? Can a customer buy more than one widget? Can a widget be sold to more than one customer at the same time? And ask those questions. You can get the basics. You could get the high level conceptual semantic model. There's customers and there's widgets and there's a relationship between them. But that's about all you could get from that initial statement.
Right? I was chatting with a guy who was a PhD, or he had his PhD in artificial intelligence. He was working for IBM. And for years, they were working on using artificial intelligence to solve medical problems. And then a couple of years later, I talked to him and I asked him if they were still doing that. And he said they pretty much gave up on it because they found out that there was so much more information in the problem domain that they didn't have access to, and they couldn't really do it reliably.
Yep. Yeah, no, that's what I would expect. There's a lot of things that can be automated easily, that are very straightforward. But then there are things like, dealing with human beings, which is not very straightforward.
I'm shocked. I'm shocked.
Yeah, I'm sure as a security analyst, you're shocked.
See, a lot of people don't realize my interest in security goes far beyond the database.
Yeah,
I mean, it's interesting. And that's going to go down. Go ahead.
You can tell a story about the engineering, or sorry, the social engineering, where the gals outside of the conference were people.
Oh my God, this was great. I was on a red team one time, and we had to break into a business. The statute of limitations is not up, so I shall not mention the type of business. All right. Or anything else about that, except that it was in a large city. And we decided the best way to break into the systems was to get people to plug USB drives into their computers. Simple. Go hand them USB drives and tell them plug them into your computers. How do you do that? We hired and this is politically incorrect, but anybody who knows me goes, yeah, well, that's Rob. We hired a bunch of really, really cute girls, and we gave them a bunch of USB drives and put them in front of the building, okay? And said, give them to the guys and say, there's a concert coming up. I hope I see you there. Here is the band that's playing. Go ahead and play it. And this is where the concert's going to be. What is the percentage of guys that took that USB that cute girl handed them, went in and plugged it into their computer at work?
Probably near 100%.
Oh, it was really close. It was over 90% because every one of those USBs phoned home. And then it's like, we broke in. Your people took that, and it's like, because I can hack the human a
Right.
whole
Yeah.
lot easier than I can hack the computer.
Right.
I can put all of these controls on the computer, but then there's the human. Just hack them. And it's fun. A lot of people don't realize I have fun hacking humans, but it's like, Candy said I'm not allowed to do that anymore. The good old days. Back before I had an employer that made me take ethics classes.
Well, we normally go for about an hour, and we're about an hour and 10 minutes in. But do you want to give us your not your credentials, but your coordinates, and so people know how to reach you? Or
Well, they can find me on LinkedIn and my website, kentgraziano.com, and
Right.
Twitter, and it's Kent Graziano. My Twitter handle is Kent Graziano. My LinkedIn handle is Kent Graziano, and my website is Kent Graziano. So try to keep it simple.
Excellent.
You're really tough to find.
Yeah, or you can just Google me, as a bunch of people discovered recently. You can Google me and find all kinds of things and papers that I wrote for IOUW 90 something.
Okay.
So,
Kent, thank you for joining us. It's been a pleasure. You need to get back up to Maryland. And I promise we are going to do this again, and it's going to involve taking the boat to a pierside bar, okay, that has crab cakes and crabs, and we're going to do this over crabs and crab cakes. What do you say?
Sounds good.
All right.
Right. Thank you for joining us.
You're welcome. Thanks for having me, guys.
All right. Y'all have a good one.
Take care. Bye-bye.
All right.
Ciao.
Bye.